You know, when we think about important numbers, our minds usually jump to the stuff we learned back in school, right? But what if I told you that's just scratching the surface? That there's this whole hidden universe of numbers, these fundamental constants that are literally woven into the fabric of reality itself.
I mean, sure, we all know about pi, but what if pi is just the beginning? What if it's just one of hundreds of these incredible numbers that mathematicians have uncovered? Well, that's exactly what we're going to do today. We're going on a hunt for them. So, let's dive in.
Okay, so let's start somewhere familiar. We're going to kick things off with the A-listers, the undisputed celebrities of the number world. I'm pretty sure you've met these guys before.
And first up, of course, is the big one, pi. You know the deal. It's that magic ratio of a circle's circumference to its diameter. And this thing is ancient. I mean, people were trying to figure it out way back in 1700 BCE. But here's the part that always gets me. Every single circle in the universe, I don't care how big or small, shares this exact same ratio. How crazy is that?
All right, next up we've got Euler's number, E. Think of it this way. If pi is all about perfect circles, E is all about perfect growth. It's the base of natural logarithms, and it just shows up everywhere. Seriously, from how your money grows with compound interest to the way radioactive materials decay. It's like the mathematical signature for anything that's growing all the time.
And of course, we can't forget the golden ratio, phi. This one's been around since Euclid talked about it around 300 BCE, and it's famous for, well, just looking good. It has this incredible aesthetic appeal. You'll spot it in the stunning proportions of the Parthenon, the perfect spiral of a nautilus shell, even in the way tree branches grow. It's almost like it's nature's blueprint for things that are both beautiful and efficient.
Okay, so we've met the celebs, but what actually makes a number like pi a constant? What does that even mean? Let's get into the nitty-gritty and break down the official definition.
So here's the deal. A mathematical constant isn't just some random number somebody picked out of a hat. No way. It's a value that is totally fixed, it's unchanging, and it's kind of baked right into the logic of math itself. It comes from a really clear definition, like the ratio of a circle's circumference to its diameter. It has to be that exact number. It can't be anything else.
And this might actually surprise you, but some of the most basic numbers we use every single day are technically constants. Yep, the number 1, that's the multiplicative identity. And 0, the additive identity. They have these fixed, super clear jobs in our whole mathematical system. They're like the humble, unsung heroes, the workhorse constants we totally take for granted.
All right, so we've got our definition down, and we've met the famous ones. Now it's time for the really cool part. We're going to pull back the curtain and explore that huge, hidden universe of constants that most people have never even heard of.
Because this is where things get truly wild. Pi, E, phi, they're just the tip of the iceberg. I mean, the actual list of known mathematical constants is massive. We're talking hundreds and hundreds of them, and each one has its own fascinating backstory and origin.
And just listen to some of these names. You've got the plastic ratio, the Dotty number, the super golden ratio, the twin primes constant. I mean, come on, they sound like they're straight out of a science fiction novel, right? But every single one of them is a real, fundamental number that describes some unique mathematical idea.
Which brings us to a really important point. This whole quest isn't some dusty, ancient history, not at all. The search for these numbers is a living, breathing field of math, and it's full of modern-day explorers making discoveries right now.
Just look at this timeline. It shows this incredible journey, right? The whole thing started thousands of years ago with numbers like pi, but it's been rolling along ever since, right up to today. I mean, look at the MRB constant. People only started digging into that one in 1999. 1999. We're still uncovering brand new, fundamental pieces of this giant mathematical puzzle.
And I just love this quote because it perfectly captures that spirit of discovery. It shows you that this whole process isn't always some huge formal ceremony. A lot of the time, it just starts with one curious person, right? Like Marvin Ray Burns, who was working on something and basically just posted online, hey, is anyone interested in improving or disproving this conjecture? That's it. That's how the frontier of knowledge actually moves forward. It starts with a question.
But here comes the twist. Just because we've found one of these constants, that doesn't mean we understand everything about it. Not even close. In fact, some of these numbers are hiding some of the deepest, most profound mysteries in all of mathematics.
Okay, let's just do a quick side-by-side. On one hand, you have pi. We've known about it for thousands of years, and we've proven all sorts of things about it. We know it's transcendental, for example. But then you have the Euler-Mascheroni constant, also known as gamma. We've been studying this number since 1735. That's almost 300 years, and we still don't know the most basic thing about it? We don't even know if it's rational or irrational. Think about that. It's one of the biggest unsolved mysteries in math, hiding in plain sight.
So, after all that, you might be thinking, okay, cool names, weird mysteries, but why does any of this matter? What's the big takeaway here? Let's tie it all together. Here's the bottom line. These numbers, they aren't just mathematical curiosities for professors to puzzle over. They're the fundamental parameters, the rules of the game. They are the grammar of the language we use to describe the entire universe, from physics to finance to biology. You could even say they are the source code of reality itself.
And that leaves us with one last, really exciting thought. If every time a new constant is discovered, it's kind of like finding a new unwritten law of nature. Well, it just makes you wonder, right? As we keep exploring this hidden universe of numbers, what new fundamental rules are just waiting for us to find them? And what incredible new secrets about our universe are they going to unlock when we do?